Okay, here's a pretty straightforward problem. It's asking you to calculate the vapor pressure of a solution that you make by putting in a non-volatile solute. Now, there is some conceptual uh, hurdles that we'll have to jump over when we get to them, but let's go ahead and move through it. So, good old Raoult's law says that if you want to know the vapor pressure of a solution, then you better know the mole fraction of the solvent and the vapor pressure of the pure solvent. Now, it does give you the vapor pressure of the pure solvent in the problem, so we're good there. We just need to figure out what the mole fraction of the solvent is. And so there's a little bit of work to do. And so let's go ahead and take everything and start converting them from grams to moles, because that's what the problem gives you. So 70.54 grams of silver nitrate divided by the molar mass, 169.88 grams. And I get 0.150123 moles of silver nitrate. Let's make a little note of the sig fig there. Let's do the same thing with water. 7.65 grams of water divided by its molar mass, 18.02 grams. I get 42.4528 moles of water. That's going to have 3 sig figs there. Now, the mole fraction of the solvent is going to be equal to the moles of the solvent, so 42.4528 moles, divided by the total number of moles. Now, that's definitely the moles of the solvent, and it involves the moles of the solute, but here's that conceptual hurdle that I talked to you about earlier. Silver nitrate is an ionic compound. And because it's an ionic compound, it actually breaks up into 2 particles when you dissolve it into a solution. And so colligative properties are not about the numbers of formula units or the numbers of molecules. At its heart, it's always about the number of particles. In freezing point depressions and boiling point elevations, we have the Van Hoff factor to take care of that. But in Raoult's law and in osmotic pressure, you have to deal with that sort of on your own. And so there are 2 particles that are associated with that. So the total number of moles of particles are going to be multiplied by that factor of 2 for silver nitrate. So the reason why I put silver nitrate in parentheses in that denominator for mole fraction is that I'm going to have to multiply it by 2 in order to correctly calculate the mole fraction of the solvent, because it's the fraction of the moles of particles, and molecules and ions are their own particles. So I get 0.993 as the mole fraction. And so really that was all the hard work. The rest of it is just 0.993 times 23.7 torr. I get 23.5 torr. That's the vapor pressure of the solution. And that's my final answer. Okay.